Hello everyone, let's talk about another medium problem on Leetcode today, maximum distance in arrays, Leetcode 624. In this problem, we are given m arrays, where each array is sorted in ascending order. Then we can pick up two integers from two different arrays. Each array picks one and calculate the distance. Then they define distance between two integers a and b to be absolute difference between a and b. And then we have to return the maximum distance. So to summarize, the distance between two integers a and b from two different arrays is a minus b in terms of, like, we take the absolute distance of a and b. So this is just one distance, but we have to calculate the maximum distance between all the arrays. Then in example 1, we can see that in the list given, we pick element 1 from array 1 or array 3 and pick 5 in the second array, and that's why the maximum distance between 5 and 1 will be 4, and that's what we have to return. So we have to pick up two elements from two different arrays such that the difference between them is maximum. So this gives us the hint that we should pick up minimum element from one array, that is 1 for example, and pick up the maximum element from another array, for example 5, and then the distance between them will be maximum. Now in terms of solution, we have two observations to make. We only care about min and max elements from all the arrays. So minimum element will be array 0 because the arrays are sorted, right? And maximum element will be last element in the array. So to get both of them, it will take O of 1 time. And we have to calculate the distance or difference between these minimum and maximum elements from different arrays. So they can't be in the same array. So one of the naive approach can be that we pick up minimum elements, say in array 1, and then for remaining arrays, we calculate the difference of this minimum element from the maximum elements of the remaining array. So that will take O of m time for first array, but then we repeat the same process for remaining arrays. So that will take O of m square time, right? And whichever is the maximum difference will be our answer. So in terms of time complexity, it will be O of m square because we are doing so many comparisons. And to reduce the comparisons, we can track minimum and maximum elements from all the arrays. So let's call them global minimum and global maximum. And the difference between them can give us the potential answer. And why I'm calling it as a potential answer? Because both global minimum and global maximum across all the arrays can actually lie in the same array. And for us to get the maximum distance, these elements should lie in the different arrays. Then what will be the next maximum distance? And the answer is either the distance between global maximum and second minimum, because we cannot use minimum as it is present in the same array. So second best option is second minimum, which can be present in different array. Or it can be the distance between global minimum and second maximum, because maximum is part of the same array. So we can't use it. And the maximum of either of these will be our answer. And along with global maxima and minima, we should also track their array number or array indices so that we know if the indices are same, then both global maxima and minima belong to the same array. Now let's take a look at this example. Here we can see that both global maximum, that is 7, and global minimum, that is 1, are present in the same array 1. So we cannot use both maximum and minimum from array 1 to get the maximum distance. So we have to calculate second maximum and second minimum, which is 5 coming from array 2 and 2 coming from array 3, right? Then our maximum distance will be maximum minus second minimum, that is 7 minus 2 equal to 5, or second maximum minus minimum, that is 5 minus 1 equal to 4. So we take maximum of either of these, so that is why 5 is our answer. Now in terms of time complexity, this solution is quite optimal because it takes O of m time only. And the reason is it takes O of m time to find the global maximum and minimum. And we can do that in one pass. And similarly, finding second maximum and second minimum also takes O of m time. Please check out the code link in the video description for more. And now the code is optimal, but the question is, do we have to calculate second maximum and minimum explicitly? And can we make our code cleaner and get rid of this if-else condition? And the answer is we don't need to explicitly check for second maximum or second minimum at all. Instead of tracking second maxima and minima, how about we track global maxima and minima till the current array, excluding the current array, of course. And then our current array can give us either of the global maxima and minima or second maxima and second minima, right? So we can apply following formula. we can check the maximum distance between the current maximum and the global minimum, and we can also check the distance between global maximum and current minimum, and then we take maximum of these two values. So that will give us the updated maximum distance updated by the current element. In case current array gives us either of second maxima, second minima, or global maxima or global minima. And once we are done, we can actually update the global maxima and minima. So if you see, this formula is very similar to previous approach, but without any if-else condition. And code-wise, it's way cleaner. So now let's see this in action. Let's look at example 1 again. We start with first element and define our global maximum and minimum, because we need at least two arrays to find the maximum distance, right? So from first array, we take the global maximum as 3 because that's the maximum element we had, and global minimum as 1. Now we go to second array. We only care about maximum and minimum, right? So here we can see that current maximum is 5 and current minimum is 4. So one of the maximum distances can be current maximum minus global minimum. So it will be 5 minus 1 equal to 4. Or we can do current minimum minus global maximum. So it will be 4 minus 3 equal to 1. And note that it is positive value because we have to take the absolute difference. And we take the maximum of either of them. So it will be 4 in this case. And now that we have updated the maximum distance, we update our global maximum to 5 and global minimum stays 1 itself, because here we got 4, which is more than 1. So global minimum stays as 1 only. And then we go to the last element. So this is our updated global maximum. And here we can see that again, current minimum will be equal to 1 and current maximum will be equal to 3, right? So if we calculate the distance between current maximum minus global minimum, it will be 3 minus 1 equal to 2. And second distance it will give us is global maximum minus current minimum. So it will be 5 minus 1 equal to 4. And then we will take maximum of either of these. So it will be 4. But we will not update the maximum distance because it was already 4. And now we have come to the end of our array. And that's why our maximum distance will be equal to 4. So this way, because we are using the current value smartly, we don't have to explicitly check for second maximum or second minimum at all. And that's how the solution works. Now let's jump into the code part. So first thing we will do is we will define our global maximum and minimum, and we can see that m is at least 2. So we can take the values from the first array. So we first get the first array list and then we get the first element in that list. Similarly for the max value, you again select the first list, but now we have to get the last element using array size -1. So we do arrays dot get 0 dot size -1. And now we will define our answer. Maximum distance equal to 0 initially because it's absolute value, so it can't go negative. So this can be our minimum value. And we will update it to the maximum value over the course of time. And now we will just go through the arrays list and get the current array for cleanly getting the current maximum and minimum rather than doing it this way. And we are looping from I equal to 1, right? Because we have already taken care of the first element. And now our current minimum will be equal to current array's first element, and current maximum will be equal to current array's last element, that is current arrays dot size -1, right? And now we will update our maximum distance before updating the global minima and maxima. So that will be mat.max of maximum distance, and we take the absolute value of current max minus global minimum, right? Similarly, we will do the same thing for global maximum and current min. And now we will update our minimum value based on the current array's values. Similarly, for the max value as well, we have to use max function and pass the max value, right? And that's it. And once we are done, we will just return the maximum distance. Now let's run this code. Cool. Let's submit this code. Cool. In terms of time complexity, it is O of m, where m is number of arrays basically. And the reason is we are just running one for loop and we are just getting the minimum and maximum element from it and comparing the values accordingly. And in terms of space complexity, it will be O of 1 because we are not using any extra space. The code link is in the description below. If you are interested, I have shared the solution using second maximum and minimum along with the current solution in that link. I hope this video was useful to you. If it was, please like and subscribe. Have a nice time. Thank you.